Okay, I'm back. I'm doing the second problem on the back sheet of our practice test with the parametric equation problem on projectile motion. All right, you've got to imagine that maybe it's a lacrosse ball. It's being thrown from a pretty great height. 3 meters is pretty far up there. It's in meters. You'll be told on the test what kind of units. Dead giveaway is this. That's the strength of gravity in meters. So you'll have two equations. You'll be told it's parametric. If you're not told it's parametric, assume it's function notation. If you go down in your menu, I'll show you in a minute, you want to make sure you're in the correct mode. Anyway, when you get to parametric mode, you can type in for x that it's 13t. That's the equation given to you. For y, you type in very carefully what you're given. Make sure you get the symbols correct. And then you can start to graph. Now I'm going to show you in your calculator right now. I guess that I'm getting away from the computer version. I think this might show a little more clearly. I thought the other one was a little bit dim. Here's our calculator. To get into your correct mode, make sure you just press that mode button right there. And then you want to make sure you're over here on parametric. You just go down, and if you want to get to function mode, hit enter. If you want to go back to parametric mode, go there and hit enter. And then you can quit out of it, and when you hit y equals, you'll see you'll get your two equations for x and y. There's equation 1, here's equation 2 with x and y, there's equation 3, and so on. Okay. Now, do you notice a problem? Have I typed everything in carefully? It looks like I have. There's still a problem. That is that plot 1 is turned on. Make sure all of your plots are turned off. If you loaned your calculator out, someone might have been plotting points. Also, make sure you don't forget the squaring or the variable. It's easy to do that. Now I go to my my window. If it's left in a standard window like this, you got to be really careful because we need this to reflect this particular problem. This is for 360 degrees. We've got a projectile that's going through the air for just a few seconds, so we want to make this no more than about 10 seconds, and we want to make the pictures that it takes. This is the step. This is T is for time. And we want our calculator to take a step every fraction of a second, so every tenth of a second is good. You can go smaller, but I would not go any larger because your jumps will be too great and your error will be lost. Your accuracy will be lost. So here we go. Our x minimum in our projectile, of course, x is the horizontal direction. We're going to start at 0 at home plate if we're a batter and the ball's going into the outfield. The maximum distance, well, this is going to be a little bit of a guess and check thing, but if you're throwing something, typically you can go 20, 30, 40, 50 meters. Try like 50. And then you can have markers every 10 yards. That's what that scale is, just how often our little tick marks are. The y is the vertical amount. Well, let's see. If we go a little bit below the ground, say 5 meters below, it'll allow us to have room to display the numbers at the bottom. You can easily make that 0. No big deal. The height, again, you can make it about 50. And then often when you look at it, our scale markers, let's make that every 5. Okay. When you look at it now, you'll see that that's kind of zoomed out. I can definitely get a little bit closer. That might be enough to do the problem, but I'm a bit of a detail guy, so I'm going to go zoom in on it just a little bit. So I go back to my window. I'm going to go a little bit less in my x direction. I'll say maybe 35, and in my y direction quite a bit less. I'll go down to maybe 20, and then I'll look at the graph. Okay. Much better. Now I want to go and answer those questions on the board that you see behind me. Alright? So I would sketch the graph and label the window. It's going to look something like this. I can show it like that. I don't need to show this part of it because that's just the ball if it was able to go into the ground, which is not realistic. I'd label this from, what did I say, from 0 to 35 and meters, and here from 0 to 20 and meters, and that's good. All you need to do is label the window like that. How long is it in the air? Okay, well that's the question that we need to answer first, and I just go here and I press the trace button. There's no second calc feature when you're in parametric mode. I just need to get to the top, so by heading the arrow to the right, you can see the ball is like going through the air. When it gets to the closest point to the top, that looks pretty good. I will write down the y value. Be very careful not to write down the x value or the t value. The vertical height is there, 7.13. Okay, so I'll write that down, 7.13. And now, I didn't ask this on the practice quiz, but suppose I asked, whoops, sorry, that's the one I just answered, a little bit out of order. How high? 7.13. How long is in time? Okay, how much time is it in the air when it gets to the far side of the field and lands on the ground. I would just keep going, and it's going to be in the air. Keep going, and you can see right now that's about as close. There it's below ground. There it's just slightly above ground. I'm going to say 2.1 or 2.2 seconds. Okay, that's how long. How high was 7.1, and then how far does it go? That's the X amount, and that's 28.6. Okay, so 2.2 seconds right there. 2.2 seconds. How high was about 7.2 or so, 7.1, and then how far was, what was I say, 28, something like that, meters. To combine the two, I simply take this first one and I translate that into t as an expression of x. So I divide both sides by 13, and that will cancel, and I divide that by 13, and I get t is equal to x over 13. Then all I do is I erase each t, and I put in what t is equal to. T is equal to x over 13. I've now eliminated t, and I've replaced it with x's. So my equation right here is y in terms of x. And I could type that into the calculator, and I could graph it with the exact same window, and I would get the exact same curve. Maybe you can try that. Okay? So as far as setting the window goes, you just need to make it as realistic as possible. If it's a bullet, it might be big distances. If it's a tiny little piece of rubber band that you're shooting or something, it might be much smaller. So you need to adjust it to what makes sense to you. All right? Good luck.